चेहरे लॉल नाइस नाइस स्ट्रीम दिख रही है मेरी हेलो हेलो
हेलो। हाँ दिखे बस।
मेरी स्ट्रीम दिख रही है क्या तुम्हें नहीं दिख रही वाओ
मेरा माइक कनेक्ट नहीं होता, क्या कहते थे?
स्टॉप
पैरेंड्रम
स्ट्रीम
हुआ क्या था? अच्छा,
अरे मैं तो दिया ही नहीं, मैं तो चिल करने आया हूँ बस।
हाँ ठीक है तो
पैरेंड्रम वाला सिर्फ सेक्सी क्वेश्चन, बाकी सब तो ठीक।
नेक्स्ट कैन ड्रॉ चलो यही है ना हाँ हाँ तो लेट्स स्टार्ट विथ एंट्री चेक हाउ
तो
आर वी
स्ट्रीम कर रहा है क्या?
supposed to solve it हाँ streaming so
YouTube?
how are we supposed to solve this problem okay it's working great how do we solve entry check so the problem says that I am given an age called x and if this value is greater than or equal to 10 I am allowed to enter or do some activity else I cannot do some sort of an activity right so this is so this you have to take input of x and just check if it is greater than equal to 10 if it is then print yes else print a no simple as that and this was entry check if you want to see the code let me show so that's about it that's the code and moving forward we have opposites attract now what is this thing this thing says that I'm given a binary string 1 0 1 0 1 1 1 any binary string is something that consists only of ones and zeros now if I am given this string and I need to make another string where the character at the ith index is not equal to what it is in S. I need to make another string T where I need another binary string T where let's say this is index I or index 1 and I don't want a 1 over here. So any other thing will obviously be a 0, 1, 0, 1, 0, 0. So you can just iterate over this string and if you have a 0, print a 1. If you have a 1, print a 0. Simple as that. And if you want to have a look at the code, so this is basically it. You can take input of the string and once you have taken the input of the string, you can print 1 minus whatever value it had. So this thing will give me a value that is 0 or 1. This thing will just inverse it. So if it is 1, it will convert to 0. If it is 0, it will convert to 1. And since I want to print a character, so this is basically what we are doing. In without this also it should work and we just remove the character part. But okay, fine. Now coming to the next question called Hamming equivalent. What is this? Okay, so you are given an array, not an array, but a palindrome where you have set bits. Set bits is the number of ones in the binary representation of that number. So let's say I have a number 6. So I have a number 6. So 110 is its binary representation, right? And what is the number of set bits? Basically, the number of ones in this binary representation. It is 2, right? And let's say I have another number called 10, 10, 10. This is the binary representation of 10. And how many set bits are there in this number? It's going to be 2. And here also it's 2. So if I have a 6 here and I have a 10 somewhere here, can I just swap these two? Absolutely. I can swap these two numbers. Now I need to swap these two numbers. So what can I do? that I can just maintain a map where I have my key as set bits, and on the other side I have my numbers. I have all of my numbers that are that have this amount of set bits. So I'll have a 6, I'll have a 10 and stuff here. Now what I'll do is I'll just keep on putting them in the array. There was a 6 over here in the array. Let's assume there is a 3 over here also. Okay. So in my set bits, I also have a 3. So there was a 6 over here in the array. 3 also has 2 set bits. If you are wondering, it's 1, 1. It's binary representation. So I have 2 set bits over here. So I need to put a number that has 2 set bits. So I can just put in a 3 over here. Why? Because it is I want my permutation sorted, and I can only swap numbers with uh, equal amounts of set bits. And now why will I put a 3 over here? It's because just think of it as a bubble sort kind of thing. You can just swap any two elements and you can bubble sort and get your 3 over here. You can get your 6 over here. But you can swap only 3, 6, and 10, these positions. So you will get the minimum element here, now the second minimum element, and so on. So over here, you can maintain a map, set bits, and over here you can just maintain a set or a priority queue, whatever you want. And in the set, you just keep on removing the smallest element. That's it. Or you can sort this part and then remove smallest elements and stuff. Completely fine. Implementation is up to you. So let's just look at the code. I believe you'll understand it better if we have a look at the code. So, so how do I calculate the number of? Okay, so how do I calculate the? I'll just shift this code to my Sublime. It will be easier for you all to see. Okay, so the first thing is we are taking inputs, and I am getting the number of set bits in A, and I'm just maintaining a map of sets. Now, how do you get the number of set bits? You literally iterate through the binary representation of a number. Now, how do you make this binary representation of a number? It's the standard method itself. Let's say I have a 10 and I want to make its binary representation. I'll have a 0. Like basically, I'll divide it by 2. Whatever the remainder is, I'll store here. And I have a 5. I'll divide it by 2. Whatever the remainder is, I'll store here. Now, 5 divided by 2 is 2. Floored, basically. It's 2.5, but we remove the point. And this will be a 0, 1. And I'll have a 1 here. And I'll have a 0 here. So basically, this is what, and this is our binary representation. We need to count just the number of times this 1 comes. So basically what we are doing, we are taking this number, we are calculating a mod 2, we are checking the remainder when divided by 2. If it is 1, we are adding it to our answer. So this is what I'm doing. If divided by 2, if it gives me, it will give me a 0 or a 1. And if it gives me a 1, I'll get the set bits, and then we divide it by 2. So this is how we can get the set bits of a number. Basic algorithm. You might have done this in 11th, 12th, some class. And so here we are maintaining a set. And after that, I am just checking. Assume I'd have some stuff, and I probably cannot sort this permutation. In what cases will I not be able to sort this permutation? Let's say I have a 1 here and I have a 3 here. I have a 2 here. I have a 5 here and I have a 4 here. 1 can never go here. There is no other option. Like it just can't. It can swap with 1, 2, and 4, and 3 and 5 are going to be able to swap. So this is the best sorted version I can get in the permutation. And this is not sorted. So yeah, so that's how we solve this question. Any doubts? This was a bit on the harder side as compared to others. So any doubts in this question?
Um, like I had.
No.
Okay.
I think I had. I think I had a better approach here.
Okay.
So what I did was I just traversed over the array
Huh?
and checked whether the set bits of the current element and the element at which like with
It
which you will
previously
be
arrived. So
no
if
no
it is
if
greater, you just swap.
no if the set bits are not equal, then you just flag equal to 1, and then you can just say that you will not be able to sort the array. That is what I was.
What? Sorry.
Uh, like if you'll open my code, then I will be able to.
No. Just tell the approach like this. Na, I can't open the code.
अब मैंने भी वही अप्रोच किया था मतलब आफ्टर सॉर्टिंग द एरे जो वो सॉर्टेड इंडेक्स पे जो एलिमेंट है और जो
Oh,
original
okay. So you are sorting this to 1, 2, 3,
हाँ
4, and 5, and works. Correct. Completely fine. This works. This works. Correct. So the number of set bits over here and the number of set bits here have to be the same. This is in fact a better approach. Just n log n. Big deal. Yes. This is a better approach. You can just do this. Yes. That works. So for those that want to understand their approach, we have an array over here, and let's say it's not sorted. We have 5, we have 1, we have 3, we have 2, and we have 4, something like this. Now he's saying that he'll sort this array 1, 2, 3, 4, and 5, and I'll just check the number of set
There
bits.
is no need because it's a permutation. So you just check if I'm at a 5 can pull them again.
Yes, since it's a permutation, at 1 I should have exactly the number of set bits that 1 has, exactly the number of set bits that 5 has, exactly the number of set bits that 3 has. So as 5 has, let's say, 2 set bits, and at position 2 I have 2 which will have only 1 set bit. So I want a 2 here, but I have a 5, which is not correct. So yeah, over here I'll just remove this. Yes, no need to sort also, like implementation stuff, small. So O of n log n solution. And if you use some pop count, or I don't know, there might be some inbuilt function to get set bits in O of 1. I don't know. But this is how you can just solve it. You got the gist of it, that at index I require exactly x set bits. If my number at index I does not have x set bits, then I'll just get a no, else I'll get a yes. I need to check this condition for all i's. Okay, that's good. Now, most k frequent, let's see, what was this question? Okay, so we are given an array over here, and I want to make some element k that is present in this array the most frequent element of this array. And let's say it's somewhere here and here. Okay, so in one operation I can remove the whole prefix or a suffix of this array, and I need to tell the minimum amount of operations that are required to do it. So the operations required, I am claiming, is 0 or 1 or 2. Now, why is this so? Because if I require 0 operations, let's see the case of a 0. When will I require 0 operations? When the frequency of a k is maximum itself in this array. Like I have A, I have B, I have C, and I have another C. So k has the maximum frequency, and I don't require any kinds of operations. Now, when will my answer come out to be a 2? 2 is when I can always get my answer to 2. I'll just remove a prefix before certain k, and I'll remove the suffix before a certain k. There is just one element left in the array. I'll remove both these, and it is the most frequent element. So I can always have my answer 2. Now we just need to check if our answer is 1. So how can we check if our answer is 1? We just keep removing a suffix. We will either remove a suffix or a prefix, right? So we just keep removing a suffix and keep checking what is the most frequent element. And same thing for the prefix. We just keep removing it. And once we now know that, let's say if I remove this, uh, let's assume there is uh, these are all a C. Yes. So if I remove this prefix, is it still the highest? Okay, I remove this prefix, is it still the highest? That's how you just have to check. So how can we just implement this? I'll just show you the code. It's better to see here. So I'm taking input, I'm keeping track of the maximum frequency, and if k has the maximum frequency, I am just printing 0 straight up. Now my answer is 2. We proved that we can just remove any 2 of these. Like, yeah, my answer is at most 2. It can't be anything apart from 2. So we just keep on iterating and we keep on adding. So basically what I am doing is I'm saying that I just kept this much of the array and removed whole of this. So I removed this. Do I get an answer? Is k the maximum frequency? I removed this. Is k the maximum frequency? I removed this. Is k the maximum frequency? Remove this is basically the same as keeping all of these, right? So that's what I'm doing. I'm taking the max frequency. If k becomes max frequency anyway, so I'm just doing it. And I'm iterating backwards also. So that's it. And we just print our answer. And I got an AC. Any doubts in this problem? Hello? Hello? If it's a no, please do tell it's a. Or if you don't understand anything, it'll be better for me to also understand so that I can.
Could you explain how the answer could be 2 at max only?
2 at max only. Okay. So I have a k present in my array, right? This much you understood?
Yeah.
Now I'll just remove all the elements before k and all the elements after my k. This is one operation. This is one operation. The array remaining is just k. It is the most frequent element in the whole array.
Okay, yeah.
So 1, 1, and it is at most 2, right? Understood?
So जितने भी के है इसमें सारे के लिए ट्राई करना है कि कोई भी.
No, any k you will remove, na. You don't need to check for the 2 ka case, because you don't need to tell which prefix you have to remove. You just need to tell the minimum number of operations. Now minimum number of operations. Now if it is just one operation, then I'll just check with every prefix, right? I'll just remove every prefix and check. I removed this. I removed this. So basically I removed the whole of this thing. It is the same as just checking the frequency of this one thing. Now I removed all of this thing. It is the same as checking the frequency of this thing and this thing. I had checked this thing in the previous step. Now I'm just adding this new element and checking the frequency again. I removed it. Understood? Okay, great. Any more doubts? I'm assuming there are no other doubts. So let's move forward.
Like this would work like constraints come था इसके लिए like 20 तक ही था.
No, like even if my k is anything, it will work. This is an O of n solution. I have time complexity O of n. O of n log n, because I'm using a map for frequency. If you use an array, then O of n. The best solution you can come up with is an O of n solution, where O of n log a rather than n log n. But yes, so I have a k. So yes, I'm just parsing it once, right? Here, here, and here. No need. So even if you see the code, there's one loop, and over here also I'm just going in one loop. That's it. So the best case is O of n if you use a frequency array, because I used a map because it's easier. But any more doubts?
No.
Huh?
No.
Okay. So let's move on to the next question, the final question that I solved. When I started the contest an hour late, so I was only able to solve till here. Okay, what is this? Okay. So you are given a sequence of positive integers. So you have positive integers and you have negative integers. You are given a sequence of those positive integers and you are given a sequence of those negative integers. Okay. Now, what you need to do is you need to make an array out of these numbers. You can say positive as non-negative, like 0 included. Okay. So just keep that in mind that 0 is included over here. And now, how am I supposed to? Now, I need to make an array of all these numbers such that its maximum subarray sum is minimum. That is my first constraint. And the second constraint is that all the positive numbers should be in the same relative order as before. So let's say I have a 1 here and I have a 2 here and I have a 3 here. So in my final array also, I should have a 1 before a 2, and that 2 and both 1 and 2 should be before the 3. Let's say I have another 2, I could have another 2 here or here, it's fine. And let's say I have a 4. I can't have my 4 here. I can't have my 4 here. Neither can I have my 4 here because it breaks the order. If I were to again just take all of these positive elements, I should get this array back. Okay, this much you understood. This is what the question says. We need to maintain this relative order and the maximum subarray sum. So this is something, and I have a subarray. So let's assume this subarray gives me the maximum sum. So the maximum sum of some subarray, and my subarray can be empty, for which the maximum sum is 0.
By the
So
way, even for negative numbers, the order should be.
what?
Even for negative numbers, the order should be.
Even for negative, yes. So that's just for positive. Even for the negative numbers, the order should matter. Has everyone understood the question until now? Please, a yes or no?
Yes.
Okay,
Yes.
great. So one by one, I'll just keep on putting elements. Okay, so what is the best strategy? Let's say my maximum subarray sum is some capital X, right? I don't want to exceed capital X. Okay, but okay, before this, you should know how to calculate maximum subarray sum, right? So a very nice and elegant method is you can take every one of you know prefix sums and how they work, correct? Hello.
Yep.
Okay, so prefix sum is basically, if I have 1 here, like element 1, I'll have 1 plus 2, I'll have 1 plus 2 plus 3. So it's basically the sum of all of these, sum of all numbers till that particular index is what a prefix sum is. Now, if I want to get the sum of a range from L to R. So I'll just do prefix of R, basically all numbers still here, minus prefix of L minus 1. Why L minus 1? Because I don't want to subtract this number. I want to subtract this number. Anything before that. So I'm subtracting everything before this. So, and I am taking everything from here. So I get the sum in this range. Okay. So this much I believe everyone knows. So going forward, how can we use this to find the maximum subarray sum? We do not need to find the subarray. We just need to find this one number. Correct? So let's assume I have some prefix p up until here. How do I know if my array is ending here? What is the maximum subarray sum that I can get? I would want answers from your end. Just think about it a bit. My array is ending here. What will be the maximum subarray sum for a subarray that is ending over here? How can I get that? Just think about it. I'll give you 2 minutes ish. So it's 10:36, 10:38. We can move ahead. I'll just tell a solution. Just think of it. And if you get the solution, directly just prompt out an answer. I'm fine.
Like there is only one end.
Yes, this is the end of it, but you don't know the start. Let's
So now
assume
we
this
can
is the end.
calculate prefix sum from there,
Huh?
assuming it was 0, like maybe.
Yes, let's assume starting is 0. And my
Now
array
from
also
there-
consists of negative numbers, right? Positive and negative both. And I want the maximum subarray sum of this. Hello. Just a minute and I'll just tell a solution if no one prompts.
Like
Hmm.
we can make a counter if like maybe like we can use any algorithm like Codechef algorithm, like
Huh, I am asking in this case using a prefix sum. Cadence is there. But in this case, if you have this prefix sum and your subarray is ending here, what is the maximum sum that you can get when the subarray ends over here? Is what I'm saying. Basically, what you want is, if you want to find the sum of a subarray, you will have prefix r as set, and you are going to subtract a prefix l. Now you want to maximize this value. This means that you will want to minimize prefix of l, correct? So whatever is the minimum number of all of these, rather even this also, if I want subarray size 0, then I can get my maximum subarray sum for an array that ends here, correct?
Yes.
Because I want to minimize this L. So it's the minimum of these. Okay. So now that you know this, we can move forward. How do I make this? How do I construct? Let's say I have a maximum subarray sum limit of x. I can't exceed an x. Currently it's 0. I just put in some sort of a positive number, p1. It still isn't exceeding x. I put in a p2. It still isn't exceeding. I put in a p3 also. It still isn't exceeding. But now if I put in a p4, this exceeds x. Okay. So now it's time to put some sort of a negative number, correct? So that it does not like I can't put any sort of a positive number. So my only option is to put a negative number. So I put a negative number n1. Now I again try to put a p4, but still my maximum subarray sum exceeds this value. Now one more thing, did you understand that we can keep on calculating the maximum subarray sum as and when we are adding the elements over here, correct? So up until here the maximum subarray sum should not exceed x. Up until here it wasn't exceeding, till here also it wasn't, till here also it wasn't, here obviously it won't, because it wasn't till here. Then I'll just put in another negative number now. So basically you can take a prefix, keep maintaining a prefix, keep maintaining the minimum prefix value, and you can keep track of this subarray sum such that it does not exceed my x. Okay, wow, that's great. But let's assume I am just over with a p4, and now I have n2, like I can put a p4, I put an n2, and now I am over with negative numbers. Now I just have positive numbers. So I'll just place all those positive numbers and check the maximum subarray sum. Now I was able to anchor my function, this thing of getting it, because I had this x, right? Now I'll just put in a p5 and let's say a p6 also. And this, my array got over. Now I'll just calculate the maximum subarray sum and check if it was greater than x or not. But who was going to give you this x is the question, right? Now you have your array, but how did you find this x? Okay, so one thing that you can think about over here is, sorry, what? Somebody interrupted? Okay, no. One thing that you can think about over here is that if I can make a prefix sum, or sorry, if I can make an array with a sum of, let's say, y, right, I can easily make an array that has a sum greater than y. Am I correct? That has a maximum subarray sum greater than y. Correct? Am I? Hello? Please, a yes, no.
Yes, yes.
Okay. That's great. Now I can make another that is greater than y. Okay. Now what? Now I need to find the minimum value of such y that I want it. So if you see, it's no, 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 up till a certain point, and then it becomes a rather, it's like no. For this y, it's a no. For this y, again, it's a no. Again, it's a no for another y. And then there comes a certain y where it becomes a yes. Yes. And for everything ahead, it's a yes. I just need to find the smallest of these y's, right? So I can binary search on them, right? And did you understand why am I able to make, even check if this is possible? This won't give me the smallest value. This will just tell me that it is possible to make an array whose maximum subarray sum does not exceed a value x. That is the only thing that I am getting. So if it does not exceed this value y, I don't need to check anything else ahead, right? And if it does not, like if it exceeds this value n, I need not check anything else behind. So basically we can just binary search and then get our answer. This is our check function. Now coming to the code, how are we supposed to do it? So here is the code. So I had written this one before. So this is basically getting the maximum subarray sum that I just explained. I'll explain below also. You get inputs as positives and negatives. Negative dot pushback x, positive dot pushback. So I am getting positives and negatives as an array. Basically, these two arrays I am getting, taking input. Now I'll binary search. My minimum sum is going to be, minimum value of the maximum subarray sum is going to be equal to this 3. 3, or rather the maximum element. So my left is maximum element and right is sum. So basically my maximum subarray sum is, let's say I just don't put any negative, so sum of all positives. That's exactly it. So we have a target sum x, and if we just, and this is what I'm doing. If I don't have a space for a positive, just keep on putting positives. If you don't have space for a negative, sorry, keep on putting negatives. If you don't have space for a negative, keep on putting those positives. You can't do anything else. Now if my prefix plus the positive, basically I added this element to my prefix. So my prefix is changed, has changed to this, minus the minimum prefix that I get. The minimum prefix that I said earlier should be less than equal to the target sum. Basically, there should be no subarray ending here such that the sum is greater than target sum. So if it does not, we can just put in the positive, else we have no other option but to put a negative. We update our prefix with whatever value that was put, and also update the min prefix. Now after making this array, we just get the maximum subarray sum. Now why am I getting it? Why can't I get it directly from here? Because in the end also I'm adding these values and I'm not calculating stuff over here on the fly. That is the main reason. I'm just calculating here. It's just black boxing. And if it is greater than my target sum, basically a no value. So we just go one step ahead. And if it is a yes value, then we come here. That's it. Understood? So that is how you solve this, and you will get an AC. Hello. Okay, great. Any doubts over here? If you don't know binary search, or if you want to ask something, you had some different approaches or stuff. Okay, great. I think we can end our discussion here. So that's about it, what we had to do. And that was the final problem.